Good morning, guys. Welcome to the next lecture of the series. In the last lecture, we discussed about hashing, and we also saw that there may arise collision problem if two different keys point to the same index. So, in today's lecture, we will be talking about the collision handling techniques. Basically, today we will be looking at separate chaining. So, first of all, I would like to give you an example that how collision can take place. Let's say our hash function is h of x equals x mod n. Over here, n refers to the size of the hash table. Let's say the size is 4. 0, 1, 2, 3. Okay, and we have the first key as 4, so it would become h of 4 is equals 4 mod 4, and this is equal to 0. Let's say the second key to be inserted is 12, so h of 12 will become 12 mod 4, that is again equal to 0. So h of 4 as well as h of 12, they both want to be placed at the index 0, but we know that this is not possible. We can only have one key placed at a particular index. So what to do in this case? Over here, the idea is to make each cell of hash table point to a linked list of records. Like this can be made like a linked list which has the same hash value function. This means that h of 4, the 4 will come in here first, and then h of 12 can also come in over here. Let's say we have key as 16, then we will have h of 16, that will be equal to 16 mod 4. Again this will be placed at the index 0. So now we have a linked list consisting of all the keys placed at the index 0. So this is how the separate chaining works. Now what are the advantages of separate chaining? First is, it is very simple to implement. Secondly, the hash table will never fill up. That is, we can always add elements to the chain. Third, it is very useful when we don't know how many and how frequently keys may be inserted or deleted. After all of these things, we need to know about the performance of open chaining. So, the performance can be evaluated under the assumption that each key is equally likely to be hashed at any slot of the hash table. Now, to just analyze the performance, we have to understand a few basic things. Let's consider m to be the number of slots in hash table, n to be number of keys to be inserted in the hash table. Then we say that load factor alpha, this is equal to n upon m. So after we find out the load factor, that is n upon m, we can say that the expected time to search Let me write it down for you. This would be expected time to search will be big O1 plus the load factor alpha. The expected time to insert will be big O 1 plus alpha again, and the expected time to delete would be the same big O 1 plus alpha. So the time complexity of search, insert and delete is big O1 if alpha is big O1. But chaining has got its own disadvantages. First and foremost, cache performance of chaining is not good as we are using a linked list to store keys. Also, there is wastage of so much of space as some of the parts of hash table will never be used. Third, in the worst case, search time can become big O of n. And fourth, also we are using extra space for links. Therefore, we have to come up with a better collision handling technique. Hence, in the next video, we will be learning about open addressing. This is all for today's video. I hope you liked it. Thank you.